Hello guys, welcome in our new lecture ortho orthotropic deck surfacing and truss bridges. In this video we are going to cover these two topics. So let's start. Our first topic is orthotropic deck surfacing. Its topic number is 6.8.5. The wearing surface on a steel plate deck should satisfy the following requirements. Number 1. To reduce dead weight on the deck, the covering should be lightweight but of sufficient thickness to cover all irregularities of the steel surfacing and thus provide an even plane traveling surface. So this is the number 1 point. And the number 2 is to increase friction, minimize ice hazards. The surfacing should possess skid resistance. Stability and durability should be maintained over the entire expected temperature range under the action of the traction and braking forces of the vehicle. This is the number 3 point. And number 4 is a good wearing surface should provide permanent corrosion protection, be impervious to water and chemical agent, develops no crack through which moisture can penetrate onto the steel deck, and having a good bondage at the surface of the steel under all conditions. We have discussed these 4 points about orthotropic deck surfacing, how to cover the deck surface of the bridge. Now this is the conclusion. This paragraph is the conclusion of these 4 points. For various reasons, preferences has been given to such bituminous mix wearing surfaces as asphalt, concrete, and asphalt mastic. Usually an appropriate insulating material is applied to the steel deck before the wearing surface. This protective layer provides positive corrosion protection for the steel deck and improves the bonding between the covering and steel plating. So this is our first topic, orthotropic deck surfacing 6.8.5. Our next topic is truss bridges. And there are many type of bridges, suspension bridges and other type of bridges. In this we are going to cover truss bridges. Topic number 6.9. Trusses are lattices formed of straight members in a triangular pattern. Trusses are classified by the manner in which various systems of triangulations are combined. The top and bottom chords may be parallel or inclined. The truss may be simple span or continuous, and the end members may be vertical or may be simple span. A highway or railway truss may be defined by the manner in which it supports the load it carries, such as a duck truss, throw truss, or half-throw truss. The duck truss is built entirely below its load. The load passes between the truss of a throw bridge and below an overhead bracing system. A pony truss is a type of half-through truss bridge which, because of its shallow depth, does not have an overhead bracing system. The most common form of bridge truss is the Warren truss. Fig 6.9a shows, as with the most other trusses, the chord carry the bending moment and the diagonals carry the shear. The vertical members carry only the panel loads and can. These are the truss bridges. You can clearly see the throw deck, ordinary with counters, and these are we can find the optimum height of the truss by this formula or you can see the